In science fiction, a laser is commonly used as a cutting tool. While the same is true for the real world, scientists at NASA's Jet Propulsion Laboratory in Pasadena, California, are finding ways to use lasers for communications as well. One day they might even be able to provide live-streamed video from Mars. Jessica Egan with the station's Payload Operations Integration Center at NASA's Marshall Space Flight Center in Huntsville, Alabama, caught up with the mission manager for the Optical Payload for Laser Comm Science, or OPALS experiment.
So what we're trying to do is transmit data over a laser beam, which is very focused, as opposed to a radio frequency beam, which diverges quite a bit over time. And because we have a focused laser beam, we can get a lot of data to the ground. So with higher data rates, we can get data moving faster, and we get things like high definition video across that data stream. It's very important for going out and exploring and getting our science data back to the ground.
Why is the ISS an ideal place for you to do your research?
The ISS gives us a platform that's already existing. It's an existing infrastructure. You can think of infrastructure used today, like using Windows on a PC. That's a platform. The ISS is a platform, and that gives us a window really to look down at the Earth and to demonstrate and really use this optical link as a test bed, as if we're in the laboratory. It rotates over the Earth just like an orbiter would rotate over Mars. And we can test things out like what if a Mars rover were to communicate with an orbiter in space? We can test that out by communicating between the ISS in Earth orbit and a ground station on the Earth, and test out those technologies. So you can imagine now Curiosity, the rover, has been on Mars for about a year now driving around, and currently it takes minutes to almost hours to get just single images down from Mars. And that's just because of the bandwidth and having to relay all that data through various orbiters along the way. If we have optical comm, you might be able to get streaming video from the surface of Mars. And I think that's a game changer in terms of public outreach and getting the public involved with Mars, and also science and getting detailed science and being able to react to things in real time and do the science a lot faster. We're an external payload, so what they're going to do is mount us in the trunk of the Dragon, which is on the underbelly. We're almost upside down, kind of like in a bat cave. We'll launch the SpaceX rocket, and we get up to the space station. The Dragon will phase with the space station, get within a few hundred meters, and then the robotic arm comes out and grabs the Dragon, opens up the trunk, just like you'd open up your trunk on your car, pulls out OPALS, and relays us in about 3 or 4 hours over to our ELC location, which is basically a pallet on the outside of the space station that points down towards the ground. And at that point, we're ready to go. We're ready to start optical communications. Our baseline mission is about 90 days, and that's just to get one video down from the space station to the ground. After that's complete, we'll go into an extended mission where we'll start to try different passes, different ground stations, different geometries, and really start to get some statistics on the data about how this optical link changes over time, changes over different weather patterns. And that will really help us when we want to design these things in the future. We'll have data on the ground, we'll have statistics that are real, and that's really important to this technology. We have been tracking the space station with our telescope at Table Mountain. What we do is we get a GPS state from a GPS, same way you get it on your iPhone, and we use that to predict where the ISS is going to be in the sky from our telescope. And so we've tracked the ISS on our telescope overhead early in the morning when it's dark on the ground, but the ISS is lit up by the sun, so we can actually see the ISS passing through our telescope, which is pretty neat to see. So the next time we'll do this, when we do it for real, we'll see a laser pointing back down at us, sending data down to the ground. It'll be very exciting.